Welcome back to the Fact Fashion Behind the Movie and Dance Show that is FFPMD. Don't worry, only name is fake, but everything inside it is pure and genuine like 24 karat gold. Question. Example. Two identical billiard balls strike a reed ball with the same speed but at different angles and get reflected without any change in speed as shown in figure below. What is 1. The direction of force on the ball due to each ball. 2. The ratio of magnitude of impulses imparted to the balls by the balls. The situation is shown in figure. In first condition, ball is directly striking the ball. In second condition, ball is striking the ball at an angle 30 degree. Now solution. Consider the mass of the ball is m. Solution of A. We have v naught x, initial velocity along x direction, is u. So p1 equals to m into u. Again vx, velocity after collision, that is rebound velocity along x direction, that is final velocity, equals to minus u, because if you consider this direction as positive then this direction will be negative. So after rebound, ball goes in this direction. So velocity, if this velocity is positive then this velocity will be negative. So we are writing final velocity Vx equals to minus u. So P2 equals to, means final momentum equals to minus u. Now we know that change in momentum delta P equals to P2 minus P1 equals to minus mu equals to minus 2 mu. Again we know that Fb x into delta t equals to minus 2 mu, where Fb equals to magnitude of force on ball. Negative sign indicates that force on ball due to wall is along leftwards. So from third law, force on wall will be along rightward direction as shown in the figure. Fb is acting in this direction, so force on wall will be in this direction. Here is the convention, sign convention as shown. Upward direction takes positive, downward direction negative, rightward direction positive, and leftward direction negative. In the second condition, it is striking in a direction like as shown in the figure with velocity u. So initial velocity will have two components, one along in x direction and one another along y direction. So here this situation is shown in here. So in this direction the velocity is u cos theta degree, and in this direction the velocity is u sin theta degree, u sin 30 degree. So here we are writing initial velocity along x direction u cos 30 degree, and initial velocity along y direction minus u sin 30 degree, because in this direction we have to take negative value according to sign convention. Again the final situation is shown here, means after striking the wall, that is rebound velocity is shown here, and this makes 30 degree with x-axis, and this situation is again here shown. So indeed final velocity in this direction, one component of final velocity is in this direction and another component of final velocity is in this direction. So we have final velocity along x direction Vx equals to minus u cos 30 degree because this direction is negative, and Vy equals to minus u sin 30 degree because this direction is negative. Now we can write in terms of momentum, that is P1 is the momentum along x-axis before collision or before striking, the mv naught x equals to mu cos 30 degree. Again P2x is the momentum after final momentum along x direction, that is m into vx or equals to minus mu into cos 30 degree. So change in momentum along x-axis or x direction, delta p x equals to p2x minus p1x minus mu cos 30 degree minus mu cos 30 degree, and this is equal to, we know that change in momentum is equal to the force applied to the time interval. So fbx into delta t equals to minus 2 mu cos 30 degree equals to minus root 3 mu. Again for y direction, initial momentum along y direction m into v naught y equals to minus mu sin 30 degree. Final momentum along y direction p2y mvy minus mu sin 30 degree same. Hence change in momentum along y direction p2y minus p1y minus mu sin 30 degree minus mu sin 30 degree, which comes out to be 0, and this can be written as fby into delta t equals to 0, where fby is the force on ball along y direction. This implies fby equals to 0. This means that there is no force in y direction. So again from 2, balls exert force on ball normally. Isolated system, the system or body or group of body on which no external force is acting is called isolated system. The system, body or group of body on which no external force is acting is called isolated system. Now conservation of momentum. According to this rule, the total momentum of an isolated system of interacting particle is conserved. Proof. We have from second law F equals to dp by dt, where F is the external force on the system. If system is isolated, then external force will be 0, that is F vector equals to 0. So from this equation we have dp by dt equals to 0. Now this will be only true when p equals to constant, that is momentum is conserved. Thus momentum of the system is constant if there is no external force on the system. Consider the bullet and gun system. For example, here we are considering the bullet and gun system. In this case, before firing, momentum of the system is 0 because there is no velocity of bullet and there is no velocity of gun. So momentum is 0. Hence we can write initial momentum of the system, that is bullet plus gun, equals to 0. Now, and we have considered it as a isolated system, that is no external force is acting on the system. Let after firing the momentum of the gun and bullet be pg, p vector g and p vector b respectively. Let fg be force on gun by bullet at time of firing. Force on gun by bullet at time of firing, and FBG, force on bullet by gun. Now from second law we know that these two force must be opposite and equal. So we can write FGB equals to minus FBG. Again from second law we know that force is given by rate of change of momentum. So we have a rate of change of momentum of gun, delta PG by delta T, equation 2, and this FBG, that is force on B due to the gun. Since force is acting on B, so the rate of change of momentum of here, this will be equal to the rate of change of momentum of bullet. So delta PB by delta T. Using equation 2 and 3 in 1, we get delta P G by delta T equals to minus delta P B by delta T. This implies delta P G equals to minus delta P B. Or this implies PG vector minus 0 equals to minus of PB minus 0. Why here we have chosen 0? Because this is the change in momentum of gun. So initially gun was at rest, so initial momentum will be 0. So here, and this is the final momentum. Similarly in this case, initially final momentum is initial momentum is 0 and this is the final momentum. So solving this, now this imply, from this we have, this imply P vector G equals to minus PB. This imply P vector G plus P vector B equals to 0. This implies final momentum of the system equals to 0. Hence initial momentum of system equals to final momentum of system. That is, momentum is not changing with time because initial and final momentum is same. So we can say that momentum of a system is conserved in absence of external force. Don't be confused with this force, because here the force on bullet and force on gun is an internal force because it is under the system. Three, consider two bodies A and B with initial momentum PA and PB. The bodies collide, get apart with final momentum PA dash and PB dash respectively. By second law, force on A due to B, FAB equals to delta PA by delta T. Or this imply FAB delta T equals to delta PA equals to PA dash minus PA vector, where PA dash is the final momentum of body A and PA vector is the initial momentum of body A. Similarly, we can write FBA, that is force on body B due to A, will be change in momentum of body B divided by time intervals. So we can write FBA equals to delta PB by delta T, or this implies FBA into delta T equals to delta PB equals to PB dash minus PB vector. Here PB dash vector is the final momentum of body B and PB vector is the initial momentum of body B. This is equation 1 and this is equation 2. See, where we have taken a common intervals of time for both forces, that is the time for which the two bodies are in contact. Now from third law we know that FAB equals to minus of FBA, that is force on A due to B must be equal and opposite to the force on B due to A. Similarly, this implies we can write FAB into delta T equals to minus FBA into delta T. This implies P dash A vector minus PB vector equals to minus P dash B vector minus PB vector equals to minus PA dash B plus PB vector. This implies PA dash vector plus PB dash vector equals to PA vector plus PB vector. This term represents the final momentum of the system, and this term represents the initial momentum of the system. So we have final momentum of the system equals to initial momentum of the system. This is the theoretical proof of conservation of momentum, which shows that the total final momentum of the isolated system equals its initial momentum.